Hello everyone and welcome to Google Cloud OnBoard. My name is Ify and I'm an instructor for Google Cloud, and today we'll be talking about Module 3, Containers and App Development. Deployment and monitoring. Alright, so that's a lot of things. So during our sessions, on our live sessions, you can ask questions on our platforms and our team is standing by to answer them. So let's get started. Okay, so containers in the cloud. Wow. So I did mention about the infrastructure as a service and platform as a service, that kind of things. And I also even mentioned that one of my favorite game, it's called Marvel Run. They build things on top of App Engine. And why is that? So let's do a little bit review. So I said, yeah, infrastructure as a service, platform as a service, those are two different things. And then there's pros and cons. So let me focus on the cons. Like compute engine itself is more like for enterprise because why? They want a lot of fine-tune, a lot of something they can customize, a lot of things they can have the full control, even like how to encrypt the data, how to do those any kind of things which is meet their requirements and then their regulations or even the compliance. So that's the one they're having all the freedoms. But at the same time, infrastructure as a service is the one that you have to take care of everything by yourself. So that means for developing, it's a little bit slower, or I would say just a little bit more things you need to take care of. Of course, more things you're taking care, you spend more time. But on the other hand, platform as a service, there's one very nice thing about the platform as a service. It's about the scalabilities. All right, because when you actually need to take care of the scalabilities, that's one of the very challenging things for all the engineers. And that's hard, and you need to do a lot of things to make sure that will be easily happened. So, for example, here, App Engine, this is a cool service which is platform as a service, and then I'm going to talk about it later on, and this is the one brings you the scalability. So basically, in short, it's you follow the framework to implement your business logic, and then the rest taken care of by the platform. So the platform itself will just easily help you to scale anything. All right, but then now you might want to looking for something just in between, and you just wanted to have the cake and eat it too, right? I mean, if you eat the cake, you no more have the cake, but you still want to have that cake, so you want two. So how are you actually going to get those? So let's see. Before we jump into the service, which is Kubernetes, or you say the Kubernetes engine, which is the full managed service that we have here in Google Cloud, let's talk about container. All right, so what is a container? So starting from the beginning, infrastructure as a service, which is those virtual machines that allows you to share those resources by virtualizing the hardwares. So the hardware is basically now that's the most on the things, and then you have the hypervisors on top, and then you have those operation systems on it, then you can run those applications on it. So for different kind of applications, of course, like a web server, database, or middleware, this kind of things, you do need some different kind of operations maybe to support them. So that's kind of the case for virtual machines. And flexibility has cost in boot time. This is exactly when we talk about virtual machines, because virtual machine, it is nice. You don't need to take care of the hardwares, but you still need to take care of those operation system. And then for them to actually boost, it spends some time. Yes, exactly. So even when we talk about our Google compute engines, yes, to spin up a compute engine, a VM, it takes us around several seconds. But to have that image, have that operation system, to get that ready and really running some of the applications, you define it, it takes about a minute. So that's kind of the case, all right? And on the other hand, App Engine, this is the one I mentioned, that provide access to programming service. So in this case, most of the time, you only focus on your business logic, and then all the rest of things, like you need some data, you need some cache, you need some storage, you need some database, and you need the network support, for example, some load balancing kind of stuff. It's all taken care by the platform. And as demand for your app increase, the platform scales your app rapidly and independently by workload and infrastructures. So that'll be something pretty easy because in that case, yeah, those things will just almost automatically scale and then going to meet the need and taking care of all the requests. So what sits in between is you said you want take the cake and eat it too. So container comes to the world. So container becomes super famous, and I think the most famous one is called Docker. So container offers infrastructure as a service flexibility and PaaS, which is platform as a service scalabilities. And this is something just simply amazing and nice because it's a layer in between the hardware, the virtual machines, and the app. So now you have a layer in between, so then your system engineer only focus on things under the scene, which is maybe the operating system, or maybe the hardware, or maybe anything that is the dependencies. Or, on the other hand, your application developers, they only focus on their app. So they will focus on those business logic, and then they will be easily to define what's the kind of like dependencies and libraries, anything they need support in something like a Docker file. So both sides focus on their work, and then they just need that middle layer in between, which is the interface to taking care of everything, and then at the end, work together. So then that's why we said, you have the infrastructure flexibilities, and then you have the platform side of the scalabilities, so you kind of get two, right? So we said containers are configurable, self-contained, and it's ultra portable. So always when we talk about container, I mean, if you go to the market and ask anyone, what's container? I mean, most people, if they are not IT, they have no idea what is that. But I mean, if they actually work in IT world, yes, of course. Container, it's portable, super portable. We always said, write once, runs everywhere. That's about container. All right, so that's exactly the thing, and you can easily to move it everywhere. And one of the things that we do here, wanting to promote, is right now you can easily to run container on Prime, but maybe wanting to manage that here on Google Cloud platforms. And even you can just run here on Google Cloud platform, or at the same time multi-cloud to run those workloads somewhere else, but taken care by us with a managed service here at Google Cloud as well. So that's something you can write once, run everywhere. Great. So with a common host configuration, you can deploy containers on a group of servers called a cluster, or in another word, what I personally really kind of into it is called fleet. Okay, it's like a fleet. Looks pretty cool. All right, so now you have a cluster, you have a fleet, and that's kind of the things. Now things become a little bit complicated because container, it's nice, it is easy to use, and there's a whole bunch of benefit. But when you have one, it's okay. If you have 10, still okay. What about you have like 1,000 or even way more? Wow. And then you have a lot of different hosts. Ooh. So in this case, a lot of those containers in a lot of different hosts, then that's a hard thing to do. So that brings us this one, Kubernetes and the Kubernetes engines. So Kubernetes, basically, that's the orchestrations. We said it make it easy to orchestrate many containers on many hosts. And by the way, this is actually something originally from Google, and then we actually just contributed to the open source world. And then, I mean, we just found that this is the technology, which is container, that we've been using for such a long time. And then we believe this is really the right ways that we can kind of easy to manage all those containers. So then we just have a new one, open source, Kubernetes, and then now it's really nice and really help a lot of people, and we are very happy with that. So let's go through this one. So what are we going to do right now? Instead of just go through all the information about what is Kubernetes, let's just go with one example here. All right, so in this example, what we're going to do is we're going to build and run an app as a container. For example, there's an app, which is app.py, which is in Python. If you know Python, good. If you don't know, doesn't matter. What we actually achieve here is just a super, super easy web page called Hello World. Okay, so that's the one. And this is the one we wanted to do, and that's the app. And for those apps, if you wanted to make it as a Docker, yes, you're going to use the Docker, or if you're going to use a Google Cloud build, that's also one of the services that you can use to build something. All right, so that's the thing. And then what we do, how do you get this app into Kubernetes? Pretty simple. You have the app, but you still need to take care of what's the dependencies. So you have a requirements and then the Docker files, and then you can see there in the Docker file, there's a lot of informations. Yes, it is a lot of informations that it says you want to run them on Ubuntu, and then you need to install some of those requirement kind of things. All right, so once you go through that, then you build and run the container as an image. All right, so one of the cool things about the container is you can actually just do a commit like those Git kind of ways you do. You just make those layers on top, and then a lot of those images just sit on top, so you can always build something based on something else. All right, so that's nice. So now we wanted to make it as an image, but then once you make it as an image, now there's the questions. Where are we going to keep that image? Are you going to keep that in cloud storage? I mean, if you want to, yes, you can, but we don't suggest, because in that case, it's hard for you to actually use them and actually hard for you to manage them. So the public one is called Docker Hub, and you can use that one, yes, but I mean, if you do something and which is private for your enterprise, you're not going to share that, right? And to install one, to have an environment to manage that by yourself is a little bit hard. So here at Google, we give you Google Container Registry. And that's a nice place that you can easily to run a private place to keep your image. All right. So now we're actually going to start to do our Kubernetes. So before I talk about this slide, let's go do something first, because I do need some support for my demos later. So what I have right now is I'm actually going to create a cluster, because that's a very important thing. So that I need my source, which is I need some environment variables. Okay, once I have that, then now I'm going to do a copy paste. Okay, sorry, I cheat. All right, so copy paste, and then now you see we have a G Cloud Container cluster, create a cluster called Air Demo. And then the zone is actually in Singapore, but I mean, I use environment variables, and then I define what's the number of nodes. So the number of nodes, it's 3. Okay, so let me click on the enter. All right, so now actually you see a lot of information, and then now this one is starting to do something. Oh, it's actually in Azure S1. All right, it's okay, doesn't matter. We're still able to do something. All right, so now let's back to our slide, because that will take a little bit of time. So we said you use Kubernetes API to deploy containers on a set of nodes called a cluster. Okay, and of course the cluster, we will have the master node and worker nodes. And the master node basically is our service will help you to taking care of the master node. So you don't really see that master node, but those worker nodes, you will actually see them in your compute engine page, because they are actually all compute engines. Okay, so we said the master runs the control planes, and then node runs containers, and then the nodes are the VMs. So they are actually GCE, which is compute engine instance. And then you describe the app, and Kubernetes figure out how to make that happen. All right, so I know it's still a little bit early, but we do have the pop-out with our questions on our platform. So if you do have a little bit of time, just go and answer those questions. And later on, I'll remind you again maybe, and then you can still go for the questions, because we just started, right? So it's okay. I mean, if you know the answers already, just go for it. Good, so here's how to bootstrap the Kubernetes engines. So, of course, that's exactly we have done it, right? Have the G Cloud Container cluster create, and then the name, then boom, you will get it. I mean, it's not like just boom, it's like nothing like a second. No, it's not. It still needs a little bit of time, but it's okay, okay? Most of the time, you don't do that kind of deployment like pretty often. No, you don't do that. you actually just done the deployment once, and then all the rest is like you do some managings. Okay, for example, you're getting more nodes or you're getting less nodes, that kind of stuff. All right, so for the machine type, yes, you can define that. If you want to, you can define what's the machine type you want, and then you can define what's the number of nodes, and then of course you can define what's the network setting. Of course, still it is run in Google Cloud Platforms, and then it's running those VMs. And then, of course, they are still in your VPC. So you're still going to use that firewall rules or those kind of things to taking care of that. So still kind of the same. Okay, still the same things. All right, so when you're actually going to deploy a container on the nodes, you use a wrapper called a pod. Okay, P-O-D, pod. So if you run a container before, use a Docker, what's the smallest unit? It is the Docker, it is a container, it is the image, yes. But when you're actually talking about like this, you are doing a deployment, and then when you do a deployment, instead of you have a container to serve your customer, that's actually something hard, because in a container, you try to minimize the things that you do in a single container. That's the best practice. So what do you do? Pretty simple. You might have several containers work together within a pod, then you start to do something. So when you're actually going to do that, we said the pod is the smallest unit for you to provide a service, okay? Again, when you're providing a service, the smallest unit is actually pod, P-O-D, pod. All right, so later on when we do the scalings, instead of scaling the number of containers, no, we actually scaling the pod. And every single pod, just like what we have on our slides, that we all have a unique IP. So yeah, it is. Every single node here in our compute engine, we do have the kind of features that supports that every single node, they can have a range of IPs, and that's going to support with those kind of like Kubernetes things, okay? So every single pod have their own IPs, so you don't need to worry about like those kind of port forwarding kind of stuff. All right, so now you can run a container in a pod using kube control. Oh, okay. So that's the open source things we're actually going to do here, because open source, that's the tool, and then we're going to use it because that means you use exactly the same things that you do on site or on your laptop, and now you just change your place to run them on Google Cloud Platforms. Okay, so now let's do something pretty simple. We wanted to run Nginx, okay? So we have a pod there running Nginx, and then we're using specific image. So let's do one deployment. Okay, so let me check. Okay, right now my cluster is ready. All right, so just let me check. What's the context I'm using right now? Okay, so I actually need to check the current context. So kube control, config, current context. And right now it is pointing to the right ones, because if you check my container list, the cluster list, I actually have 2 clusters right now. And then I need to make sure my kube control is actually connect to the right ones. So I need to check with this one, which is the current. So I will make sure the current context is actually on the right one. So it's on air demo. Yes, correct. All right, good. So what we're going to do, we are going to run an Nginx image. So let's do this. Okay, so it's kube control run Nginx, and then I need the image, and it's Nginx, and I want 1.15.7. All right, so now run it. Wow, that's fast. So once we run it, what we do, pretty simple. Later on, what we're going to do is we're going to get the pods to see where's our pods doing. So you use the deployment to manage a set of replica pods for an app or workload and make sure the desired number is running and healthy. Yes, it is. So let's check our pods. So kube control again, get pods. And then you can see exactly we do have a pods. And of course, instead of just get the pods because you have no idea what is that, you can actually set get deployment. All right, so then you can see there's an nginx and there's only one thing on it. All right, available. All right, good. So we will actually, so not us, but actually the Kubernetes engine will actually help you to taking care to make sure they are healthy and then having the traffic goes to it. So we said by default, ports are only available inside the cluster and they get ephemeral IPs. That means there's a temporary IPs, and that's not gonna the way that you serve your service or give it to the end users. No. So what happens at the end is you will eventually scale, and then that's why you use a Kubernetes, why you use a container. So at the end, you actually need to find a way to evenly distribute all the workload. So of course, you're actually going to use this one. On the right-hand side, you can see we have network load balancers, and that's the place going to really to get all the requests coming from your users. So that one have a public IP, and then with that public IP, you'll be able to get all the requests, and you can evenly distribute it to the underlying cluster with a service which is a kind of virtual interface, then distribute it evenly to all the pods. Okay, so now let's expose our nginx to the load balancers. All right. So exactly the same, kube control, and then I'm going to expose, and what is that? It's a deployment. And what's the name of the deployment? It's called nginx, and then the port I'm going to do, it's 80. And then what's the type? Pretty simple, it's load balancer. All right. So if I type everything correctly, I think I need the R here, kube control, expose. Oh, interesting. You see, typo is always there. I just need a T. It's okay. Kube control. All right. Now expose. Oh, all right. So now we'll be able to do this one, kube control, and then let's get the service. Now you see, there's two. So actually the first one called Kubernetes cluster IP, that's the one that goes to your master actually. All right, and the other one, nginx, that's the one with the load balancer. And then you can see that there's an external IP called pending what's going on here. So basically, once you do the expose, yes, now sending a request, and then Google Cloud will actually going to have a load balancer. So the load balancer is actually not in the cluster. It is actually using the Google Cloud load balancing. So if you go to the load balancing in the network service, boom, then you will see here, this is the one, this is the one. So if you click on it, and then you will see, oh, it connects to those instances of your GKE, which is your VMs. So if you go to those, if you go to compute engines, you're actually going to see those VMs running there, okay? 1, 2, 3, and then there's more because I have another cluster. All right, so that's the case. All right, so let me bring it back to my Kubernetes engines and then bring my things back. All right, so now this is one, now we exposed. And then you ask me, wait a minute, so that means I can check that website? I mean, that's actually true, okay? I mean, you guys are live, and this is really live. So if you memorize this IP fast enough, yes, you can try to connect. I mean, try not to do too much. You guys are going to crush my stuff. All right, so there's the nginx, and then this is the one. Now you can see the nginx place, and then this is the IP, and then it is exposed to the world, which is, yeah, public right now. Okay, so let's coming back here, and then now I do wanted to do maybe wanted to scale because maybe some of you guys are trying to access, right? So let's do the kube control. All right, so kube control again, and then I need to do a scale, and then I need to do, which is the deployment, which is nginx, and then I need a replica, and I want free. All right, now scaled. So if you actually just go and get the service again, And then now you have that. And then instead of that, you can also check the get deployment. And now here give you, oh, it's free. You now get free. All right, that's nice. So now you can scale. So we said you can scale also auto scaling, and this is the one I'm not going to demo. You can try it out with all the kinds of parameters, or put it behind programming logic or intelligent management. But the real strength of Kubernetes comes when you work in a declarative way. So there is a YAML file. That's the kind of way that you can just do a lot of changes all at the same time. So you kind of bring up a recipe and then show it to Kubernetes. Hey, Kubernetes, help me to do something. And then you can just easily load that, and then they will just start to do something. But what if right now we just done everything within our command line, right? So how are we going to do? Pretty simple. All right, so I actually have a script here that will be able, okay, let me switch to specific folders. All right, so there's a YAML file, and this one is actually empty right now, and then that's the place I'm going to save that. So here's the command line. You get the deploy, you have a selector to check for the nginx, and then you want them to have an output as a YAML file format, and then goes to this demo.yaml. Then once you run it, then what do you do? You actually get this one. So this is exactly the one. This is the one that you are running right now, and then here is all the informations. Great, that's nice. And then in this case, you can see, oh, let's try to change something easy and nice. You can actually change this one and make it load. For example, we wanted to scale again to change the replicas to 5. For examples. So what do you do? Pretty simple. You're going to do some applies on it. So the kube control apply, that's the way you do. And of course, you need to do some edit to the YAML files. So let's do it. So I'll just do IAM because that's one of my ways that I do all the time. So now here's the replicas, and then I'm now going to change it to 5, and then I'm going to save it, and then just double check again. So right now, it's 5, all right? The replica is 5. So now let's do the apply. Okay, so again, kube control, and then I need to do apply -f and the file. Go for it. Sounds good. All right, so now we can get the deployment, and then we'll see. Okay, now we were actually going for 5, and then now 4 is ready, and we do it again. Now it's 5 all on. All right, so that's great, right? So in this case, this is the way you can do. You can do a lot of changes all at the same time and just go apply to it. And then the Kubernetes would just take the recipe and then do everything. You actually done the changes. So you said, even to do some update to a new version of your app, you can use a variety of rollout strategies. Yes, that's something you can do as well. And I think that's one of the most famous features that we have here for Kubernetes, for this specific open source. Yeah, because they are really good at rolling updates. Okay, really good at rolling updates. So for that one, sorry I don't have the demo, but you guys, of course, can give it a try. All right, so we do have a lot of more those kind of informations here on the documents, and then you can go and check those ones from the Kubernetes website or coming from here on Google. It's all work. Okay, it's all work. All right, so now there's still a lot of topics we need to mention, so let's jump into it. So applications in the cloud. Applications in the cloud. And by the way, you guys, we just finished one part, so some of the questions is right there. Just make sure you go for the questions, okay? So applications in the cloud. So we are actually going to talk about those platform as a service, which is Google App Engines. And for Google App Engines, that's actually one of my favorite because that's starting in 2008. Wow, that's back in the day. That's a long time ago. And at the time, I'm not yet here. I'm still learning about IT stuff a lot, and then I tried it on and really amazed me because yeah, free tiers and that was a student, and then you just try something, and you put on the cloud, and then do the deploy, and then boom, it's right there. And then your application, your web application is right there running. And then they tell you, it doesn't matter how many users use it, it's gonna to work. Wow, that's something pretty cool. Okay, so let's see how it works here. So App Engine is a platform as a service for building scalable applications, and App Engine, of course, make the deployment, maintenance, and scalability easy so you can focus on the innovation. So I'll say you focus on the business logic itself, and then all the rest taken care by App Engine. And especially suited for building scalable web application and mobile backends. Okay, so I'll say, for example, the one I've mentioned, the Mario Run one, that's the one you actually build on App Engine, because that one actually needs to scale like super fast. I mean, they have no control like how much users are going to use. I mean, game those kind of things is hard, right? And when you launch your game, you want everyone to enjoy, instead of like when there's too much people, when it's too famous, then boom. Sorry everyone, our load is too much and system is crashed, and then sorry, we need to go for maintenance. Oh my God, that's not gonna happen, all right? You don't want that to happen. So of course, App Engine will be a good one, because that one is scale all the time and easily to scale to that size that really meet your needs. Okay, so let's see the standard one. So App Engine standard environment, easily deploy your applications, auto scale workload to meet the demands, and then we have some free tiers, and we have some SDKs for you to do deployment, and then to do some testing, and to do the development as well. And of course, this one, there are a lot of those requirements, and I'll say, yes, there's always pros and cons, pros and cons. The pros is like this one scales really, really fast. This is something that I've mentioned it, able to scale like 10 times, 100 times in a very short amount of time. But at the same time, you get some restriction. What is that? You actually need to write or implement your business logic in specific versions of those different programming language. For example, Java, Python, PHP, and Go, and they have to be specific versions. So your application must conform to sandbox constraint as well, which means because you need to scale very fast, and then everything under the scene also need to scale very fast. So not just the App Engine need to scale, the on-the-scene database have to scale as well. So no rights to the local file system, because anything in the local file system you cannot scale, even you cannot share. And then all request timeout have to be in 60 seconds. And every single third party, no thank you, you cannot use them. But we actually have a lot of support. So we see a typical App Engine standard workflow will be look like this. You have those instances, those we're taking care for you. You only defined the logic. So you do the development, you do the test, and then you run the web application locally, do the test. And then you use the SDK to deploy to the App Engine. And then App Engine automatically help you to scale reliably those servers, your web applications. And anything you need something like a cache, you need like a task queue, you need like a schedule queue, you need to do some search, you need to do some logging. All those things are not on the instance of your App Engine. No, it's on those RESTful API services, which is all fully support here for your App Engine. So that's the reason able to scale really fast. Okay, cool. So that's the standard one. But you ask me, wait a minute, in that kind of like standard way, yeah, that sounds very nice, but it's very hard for me. I mean, all our stuff is all in container, or we do need some specific like a third-party libraries. There's so many things, we have some dependence on it. There's nothing I can do with that. Then we heard you, so we have this one called flexible. So what is a flexible? Flexible, this one still, build and deploy those containerized app with a click. So no sandbox constraints. So basically you can write things into local, and then this one, of course, the standard one is Python, Java, Go, Node.js, but basically it's run things on container. So you can do any language that you wanted. Anything that support HTTP requests, it's okay. and then you package all your runtime as a Docker file, and then that's just easy and great, and you have all the flexibilities. So do a little bit comparison here for the App Engine environments that you have the standard environment, which is able to scale like super fast in millisecond. I think I have too much wow today, but still, wow, oh my God, millisecond, come on. This is really amazing, right? So you can easily to scale with millisecond and to that size really. So at the very beginning, I said clouds, you need to scale, but one of the more important things, you have to scale to that size soon and fast enough. So then you can really catch up with the business, right? So that's the beauty of the standard environment. But of course, pros and cons, you still get whole bunch of like no HSS, and no write to the local disk, no support for the third parties. So a lot of constraints. On the other hand, you have flexible environment. And this one, yes, scales a little bit slower, that you spend some minute to do the scalings, but on the other hand, you get all the benefits of the flexibility when you do the development, okay? So still, pros and cons, you make the choice, you make the call. All right, so now if you wanted to deploy an app, now you get at least those three kind of things, which is something in hybrid or platform as a service. And for platform as a service, you also have different kind of options. So you can go with the Kubernetes engine, which is support everything because it's Docker. And App Engine Flexible, yes, it's also Docker. You have the flexibilities to use anything like a third-party libraries. Yes, you can do it. And now you have the standard, which is the one, yes, a lot of restrictions, and then also having the framework. But this one scales way faster. So I'll say on the left-hand side is toward those managed infrastructures. On the right-hand side toward those dynamic infrastructures. Okay, so a lot of different options, and now you can just make your kind of choice. So I'll say if you do want to, for example, minimize the time to go for development, on the most right-hand side will be easier. On the left-hand side, which is Kubernetes engine, that one still need to take care of some of the things, because when the pod goes up, at the certain time, all the resource with the underlying cluster will be used. So then you do need to have a timing, start to think about how to scale, not the pod, but the cluster, okay? So there's two things you need to take care of. Scaling the pod and scaling the cluster. Those are two different things. And then for that, yes, you need to take care by yourself. But here, for App Engine Flex, App Engine Standard, that one we're taking care for you. All right, so back to the agenda here. We still have one more thing we do need to wanted to mention here, because we just tell you all bunch of different kind of like a computation options. So those compute options you have, first one is what? App Engine? Yeah, okay, you can say App Engine. You have the standard, you have flexible, you have Kubernetes, and then you have the infrastructure as a service, which is compute engines. So those things build something, but then how you're going to serve the customer, you might going to run something like API, and in this case, yeah, you wanted to hide all those complex architectures, so make it something simple. So that's the one. So if you do have those kind of things, really complex, you want to hide from that, yeah, this is the one. Application programming interface. Hide the details, enforce the contracts. So this is the way that you can kind of support your consumers, which is cloud endpoints. And this one help you to create and maintain the APIs. And we give you the RESTful API interface. And when we help you to taking care the Google API keys and also generate those client libraries. So we support runtime environment, App Engine Flex, Kubernetes Engine, and Compute Engines. And for the client, we have Android, iOS, and JavaScript. And there's another one called Apogee Edge that will actually help you secure and monetize those API. I'll say this is actually really nice one that we actually acquired this company and then join Google Cloud. and they are really good at taking care of all kinds of like API needs for any kind of like business related as well. For example, you actually going to count like how many API calls and what's the charge, what is the like queries in a second, that kind of stuff. And even now we said you wanted to run Kubernetes, you wanted to run some workload in different kind of place, for example, on Prime, on other cloud, on Google Cloud. Then you need one place as the interface to really to expose to your user, to your end users. And now you need a central place. Then Apogee will be the good one because that's the one you can actually able to support like multiple platforms and then have a central place to actually taking care of all of them. Cool. So I know we do have very limited like information here for some of our service, but we still have a whole bunch of these documents online. And of course, if you want to, there's a lot of YouTube video to talk about all these different kind of service as well. So I do suggest anyone, if you join our class today and then just join our next day and join our third day. But at the same time, you might also want to go for those YouTube videos online and then search for those keywords, then it will be easy to find them. All right, so at the end, we still have the last module, which is developing, deploying, and monitoring in the cloud. So what is the deployment things here? If you wanted to do deployment, if you want to follow the SRE best practice, first thing you need to do is version control of your code. So basically, your logic itself is based on code. The code have to be having the version control, and most of the time we use the Git. And you don't want to put them into the GitHub, like those kind of public place. No, so then in this case, you might want to have a private one. And the easiest way might not just to host one by yourself, but maybe just use this one called cloud source repositories. Oh, by the way, the question will be disappear soon. So if you haven't done the questions, go for it. All right, so this one, we have the full feature of the Git repositories, and then it's now hosted here in Google Cloud Platforms. And then this one have a full integrations with the Stackdriver debugger. I will show you a little bit later on. And then that's great because now you can do the debugger, you can do the error reporting, and then they will be all integrated with the Git here, which is the cloud source repository. So this is the place. And we also have cloud functions. So cloud function is the one that, yes, our guest speaker mentioned it, that it's easy way that you can just put those functions on it, very easy, light things, and then all the rest taken care. This is the real serverless things because you're only developing those super light functions. And they can be written in JavaScript, Node.js, or some other languages. And one of the things that's not on the slide, I do want to mention because our guest speaker just mentioned it, it's called Cloud Run. That's kind of like a new version of our cloud functions because cloud function, yes, is something that you also have the restrictions for those specific like versions of the language. And that's a little bit hard. So now we have something called the Cloud Run, which is that you develop the Docker and then you can just use anything you want because this Docker is so much freedom. And then you just run them on Cloud Run. And then we simply help you to taking care of that. And then it's just a module right there. Anytime, wait you to trigger it and then do something for you. All right, so that's for the developing. And then now what about for deployment? So deployment, we have a deployment manager. And this is one of the service that I always use to do all the kind of like infrastructures to actually provision all those resources. And this is one of the very important things because if you wanted to follow SREs, yes, you do need to make sure that everything it's able to deploy exactly the same in your testing, exactly the same in your production, and then exactly the same in your development. All right, because in that case, you can always come back and then just to do the testing. And then you know anything happens on the development, it will be exactly the same in the production. And if you found something wrong with the production, now you can come back in the testing to do some tests, and then you'll be able to solve that. So one of the very important things what we said is that instead of just having your logic, having version control, and here, even the infrastructure, make them as a code so then you can have the control of your runtime environment as well. All right, so now this is the final things, and then we really need to focus a lot of tensions here, which is Stackdriver. Because you know that Google, we are very famous about our site reliabilities, and then you don't see that Google search crash. I mean, I don't think that before, but maybe that happens before. But maybe at the time when it crashed, you check your Wi-Fi connect, not checking if our crashed. All right, so Stackdriver is the service here. We give it to our users to taking care the monitoring. And if you heard about SRE, you should know that the most important concept about it is keep iterating and then keep improving. So that's a very important thing. And then to make that able to happen is not just about the good design at the beginning, and also you need a lot of monitoring, because within the monitoring, you'll be able to capture those things happening. You need to know things are happening. And then, for example, you know that the CPU is high, or you know that the memory consumption is high, or for example, any kind of things like the request is a lot, or the request is not evenly distributed. Those kind of things is all taken care of by the monitoring. And then once you have the monitoring, you need the logs. The logs are the source of truth that you can use them as a base to make a report. And then now you start to need to do some debugging, error reporting, and those are the ones that here in Stackdriver are supported for you. And other than that, we also have something in beta called profilers. This is actually supports several different languages. I do suggest you guys to go and check the documents. And this one, we also have a quick lab there to let you go through to understand how it works. This one basically help you to check what are those CPU consumptions and then the memory consumptions. All right, so of course, I do have these slides here. We just wanted to mention everything all together. So still, one of the missing part is this trace. So trace basically give you the latency report and the samplings, and it's per URL latency and statistics. So in this case, that one gives you not just about the error happens in your business logic, but also shows you one of the very important things is the user experience. Because user experience itself, it's all about latency. So you do need to know the latency, and this is the one, support that. So you have all those 6 areas that actually able to support you for your SRE. Okay, and by the way, SRE, we have a free book online, so Google search SRE book, then you will find that one. One of the cool resource, and I really suggest to go for that one. Okay. So more resource, more things on top, and then let's run our summary and reviews. Oh my God, that's really fast. I mean, it's a day, and then our training is almost finished. So let's see what we have done. We learned about the IAM, of course, very important things, everything based on the security. So you need the security, and the things here we do in Google Cloud Platform is the IAM, which is Identity and Access Management. Who can do what on which resource? And for the hierarchies, yes, you can define those policies on organization levels, folder levels, project levels, and even on specific resource. And still, a less restrictive parent policy overrides a more restrictive resource policies. But whatever, basically, once the door is open, it is open. So IAM is kind of like a wide list kind of things, okay? So IAM, once the door is open, it is open, okay? Good. And for our compute options, of course, we have a whole bunch of different things coming from infrastructure as a service, hybrid, platform as a service, and then go for serverless. So all those things are here as options for you. And then for the load balancing, don't forget, we have 2 types of them. The global one doesn't have to be only for global. You can go for regional market, it's okay. The most important thing are those 3, they are proxied. And then those regional ones and regional internals, they are passed through. So making sure you really get it. What's the difference between the proxy ones and then the pass-through ones, okay? The pass-through ones, every request hit your backends. The proxy ones, we will take in care first and check your workload, and then we decided where to send your traffic. And then interconnect options, we have VPN, we have direct peerings, we have dedicated interconnect, and then those are for different usage. If you want something very lower level, layer 2, layer 3, then that's the dedicated interconnect or partner interconnect. And for the peerings, you have direct peerings or carrier peerings. Those are the difference, which is directly with Google or carrier with a partner. Oh, by the way, with the direct peering, once you peering with Google Cloud, that means you peer with YouTube, you peer with Google. Oh, we are actually the same company. Thank you. All right. So you peer with everyone. So if you're actually done peering with YouTube already, you're actually with us already. All right. So storage options, of course, we have those NoSQL database that supports a lot of requests, a lot of device, a lot of sensor. What is that? Big table. And then for those kind of like you need some transaction like ACID transaction support, data store. Yes. And then of course for anything binary like an image, like an audio, like a video, that kind of stuff, cloud storage will be the one. Of course you have some CSV files, POC files, anything like a structured data files, just go ahead. Cloud storage is still the right ones to keep them. And then anything relational, Cloud SQL is still the great place because relational database has been there for such a long time. If you don't need those like Superman kind of things, just go ahead, use the Cloud SQL. That one gives you the full managed one, which is still nice and easy to use. But I mean, when you need a Superman to save the world, of course, we still have the Cloud Spanner here, which is globally consistent, high available, and able to scale in flight. Then BigQuery is the one we're going to talk about tomorrow, which is the one you're able to process huge amount of data in a very limited amount of time and using standard SQL. So, wow, still our live questions. Let's see how you guys answer it. I hope you guys finally answer all things correct. All right, so what's the smallest unit to provide service to user in Kubernetes? The answer is pod. Okay, so we do have some people answer container. So as I mentioned, container, yes, when we do Docker, it's using container, but when we actually provide service, it's using pod because we don't scale container, we scale pod in Kubernetes. Okay, sounds good? All right, and then the next one, which is the service able to help you with the SRE, which is site reliability engineering. All right, so that's the one called stack drivers, okay? Because the SRE things you really need to do monitoring, you need the source of truth, and you need a lot of different ways to actually to see how to improve, how to fix something, right? So that's why we said stack driver will be the one to help you with the SRE. Because monitoring, it is the most important things here for the SRE. And then stack driver, of course, that's the one single place. Everything, every log, every metrics automatically created for you is all there. So now you don't need to build those systems, build those things to monitor things because it's all there already. You just need to go and check how nice it is. So next questions. Which is the one you might want to consider when you have very little time for development and the life cycle of the app is short and also want to use some third-party libraries. Okay, I give you like, I think I give you every single kind of like things. So I think, most of the people actually choose Kubernetes. I mean, I know you guys love Kubernetes and that one is also really a good answer. But when I said, I have a short life cycles, okay? And then you have very little time to develop. Very little time to develop, that means you want something platform as a service or something like a container. But if the time is short and you need to take care of those workload, which is the scalability problems, it's hard for you to manage by yourself. So I will say the better answer here will be the App Engine Flex, okay? Because App Engine Flex, do everything. You have the third party, you're still able to do Docker, but this one, all the thing taken care of by yourself. All right, so that's all. So thank you for joining our digital events, and please stay tuned for the next module.